Lesson 11-1, Graphing Quadratic Functions. And in this lesson, you learn to find the equation of the axis of symmetry and the coordinates of the vertex of a parabola, and to graph quadratic functions. And then why is it important? Because you can graph quadratic functions to solve problems involving fireworks and football. So let's take a look at this real-world application on landmarks. The Gateway Arch of the Jefferson National Expansion Memorial in St. Louis, Missouri, is shaped like an upside-down U. This shape is actually a catenary, which resembles a geometric shape called a parabola. The shape of the arch can be approximated by the graph of the function f of x equals negative 0.00635x squared plus 4.005x minus 0.07875. So where f of x is the height of the arch in feet, okay, and x is the horizontal distance from the base, okay. So this type of function is an example of a quadratic function, and definition of a quadratic function. It can be written in the form of f of x equals ax squared plus bx plus c, where a is not equal to 0. Because if a is equal to 0, this will become a linear function. So notice that this function has a degree of 2, and the exponents are positive. So the degree of this polynomial is 2, and the exponents are positive. Okay, so definition, let's go back there, is a function that can be described by the equation in the form of y equals ax squared plus bx plus c, where a is not equal to 0. Okay, so to graph the quadratic equation, you can use a table of values. The table at the right, okay, shows the distance in 35-foot increments. This table right here that they're talking about. So 35-foot increments from the base of the arch and the height of the arch, okay, at each increment. Okay, so rounded to the nearest foot. So graph the ordered pairs and connect them with a smooth curve. The graph of f of x minus negative 0.00635x squared plus 4.005x minus 0.07875 is shown below. So basically, after creating a table of values from this equation, remember this, we make a t-table out of this, okay, and then we end up with these table of values, okay, and if we graph those table of values, this is how it's going to look like. So these are the ordered pairs, okay. This graph is made up of the ordered pairs from our table of values, and this is what you come up with, okay. And if you notice that the value of a in this function is negative and the curve opens downward. So basically, if you look at the value of a is actually this, the coefficient of x squared. So the coefficient of x squared is your a, and that's your a, and it's a negative. So if the value of a, okay, is negative, the curve opens downward. The greatest value of f of x seems to be 630 feet right there. That's your greatest value, 630 feet, okay, which occurs when the distance from the base is 315 feet. So 630 feet when the distance from the base is around 315 feet. So the point 315, 630 would be the vertex of our parabola. So for a parabola that opens downward, the vertex is the maximum point of a function. And if the parabola opens upward, the vertex is a minimum point of the function. So since this parabola opens downward, okay, so the vertex is the maximum point, okay, and if the parabola opens downward, the vertex is your minimum point. That's what it's saying right here, okay. And since the parabola opens downward, you have your vertex being a maximum point, okay. And let's see how this works in our example. Okay. Before we do that, I think we need to go to more definitions, and this is the one. The fold, okay. Well, we didn't do the activity, but when you talk about the axis of symmetry, okay, each point on the parabola that is on one side of the axis of symmetry has a corresponding point on the parabola on the other side of the axis of symmetry. Okay, so the vertex is the only point on the parabola that is on the axis of symmetry. So when you talk about the axis of symmetry is simply the line that divides your parabola into two identical or two equal parts. So if this is your parabola, for example, and this is your axis of symmetry, what it's simply saying is that, okay, whatever is on this side of my parabola corresponds to that side of the parabola. So if this were a piece of paper and I fold it, my parabola will fall on top of each other. The left side will fall on top of the right side exactly. Okay, that's what it's saying here. So basically what it's saying also is that the vertex is the only point, the vertex here, okay, of the parabola that is on the axis of symmetry, and this is what we call your axis of symmetry. Okay, remember we talked about symmetry, line of symmetry in the 6th grade. The line of symmetry is the line where it divides a figure into two equal parts, okay, or two congruent parts. In this case too, if this is our axis of symmetry, whatever is on this side of my parabola will be equal to whatever is on the right side. Okay, so let's look at the equation of the axis of symmetry of a parabola. So the equation of the axis of symmetry for a graph, okay, of y equals ax squared plus bx plus c, where a is not equal to 0, is basically x is equal to negative b over 2a. So this is the formula for axis of symmetry. X equals negative b all over 2a. So memorize that. Okay, we will be using that in the next few lessons. So you can determine a lot of information about our parabola from its equation. So given the equation in example 1, x squared minus 4x plus 5, we want to find the equation for the axis of symmetry and find the coordinates of the vertex of the parabola and graph the equation. So three things we need to do. First, find our axis of symmetry, and then we want to find the vertex, the coordinates of our vertex, and then we want to graph our equation. Okay, so let's take a look at letter A and finding the axis of symmetry. So in finding the axis of symmetry, okay, so in our equation, y equals x squared minus 4x plus 5, okay, a is equal to 1, the coefficient of x squared, b is equal to negative 4, the coefficient of x, and c, okay, is equal to 5, which we don't need right now. We'll need it later on. So our constant is actually our c. So our a is 1, b is negative 4. Substitute these values in the equation of our axis of symmetry, which is x equals negative b all over 2a. Okay, so x equals negative b all over 2a. Okay, and then substitute our b and our a. That becomes now the negative of negative 4 all over 2 times 1, because b is negative 4 and a is equal to 1. Okay, and we simplify that, our value will be 2. So our axis of symmetry would be x is equal to 2. Okay, so that's how we found our axis of symmetry. Now let's find the coordinates of the vertex of the parabola. So in order to find the vertex of our parabola, since the equation for the axis of symmetry is 2 and the vertex lies on the axis, the x-coordinate for the vertex is 2. Okay, so what do? In y equals x squared minus 4x plus 5, we substitute, okay, 2 to our x. Okay, so after substituting 2 to our x, we now have 2 squared minus 4 times 2 plus 5, and then we simplify that, so y equals 1. Okay, so the value of y when x is equal to 2 is 1. Therefore, okay, our vertex at this point would be 2, 1, because x is 2 and y is equal to 1. So again, let's recap. First, we find the axis of symmetry, we find the value of x, and in order to find the vertex, we simply substitute x to our equation, and then we find the y coordinate. Now we have our vertex as 2, 1. Okay? And letter C, it's saying here now, graph the equation. Okay, so this is a little bit tricky, so Pay attention, rewind if you need to. Okay, so you can use the symmetry of the parabola to help you draw its graph. Okay, so basically now you have a graph, and then you can use its symmetry or the line of symmetry to help you draw that graph. Graph the vertex and its axis of symmetry. Okay, and then choose a value less than 2. Okay, let's say 0, and find the y coordinate that satisfies the equation. Okay, so first we want to graph the vertex and the axis of symmetry. So if we do that, let me use GeoGebra for this. Okay, so you have a better idea of what we're talking about. Okay, so first we need to graph our vertex, but we need to put the grid there first and make this bigger and get rid of that thing. So our vertex will be 2, 1. Okay, and this will be 2, 1 is right here. Okay, so mark our point. 2, 1 is right there. That's our point. Okay, that's our vertex. Now next, what it's saying is this. The next one, nope. Okay, graph the vertex and axis of symmetry. Choose a value less than 2, say 0, and find the y coordinate that satisfies this equation. Okay, so basically, we choose a value less than 2, and then we use 0, okay, which is less than 2. So we substitute that to our y. So we now to our x. So we end up with y equals 5. Okay. So here we go back to our GeoGebra. We chose a value. Okay. Basically, what it's saying is, let me make this bigger. There you go. Let me bring it down a little bit. Okay. Oops. Let me undo that thing. Okay. And let's okay, I'll do that again. Click on that. Okay, so before we graph that 0, okay, let me point out also that if you notice y equals x squared minus 4x plus 5, the coefficient of our x squared is positive. Remember in the first example, when the coefficient of our quadratic term was negative, the parabola opens downward. So in this case, if the coefficient of our x squared is positive, the parabola opens upward. So this parabola right here should open upward. Okay? So what we did was that we found a value. Okay? Remember, this is our axis of symmetry right here. Okay? Let me draw a line here. Okay? So this is our axis of symmetry. Okay, that line right there, and this is our vertex. And since our parabola is the coefficient of our quadratic term is positive, our parabola will open upward. Okay, so what we want to find essentially is you want to find the value of x to the left of your axis of symmetry. Okay, and in this case 0 was chosen, and if you notice when 0 was chosen, okay, the value of y will be equal to 5. So we graph 0, 5, and then 0, 5 is right here. Okay, you get that point. 0, 5 is right there. Okay, now the next thing is simple. Remember, when you talk about our parabola, okay, whatever is on the left side of the parabola will be equal to the right side as well. So what we need to do is simply mirror that point across our line of symmetry. We need to reflect that point across our line of symmetry, and that is this point right here. Okay, so after that we simply connect them. Okay, connect those 3 points. Okay, and if you, when we connect those 3 points, let me enter the equation. So those 3 points will connect. That would be, you connect this first. There you go. Y equals x squared. Okay, minus 4x minus 5 minus 4x minus 5. So we simply connect those 3 points and look what happens. Okay, oopsie. Why did it go down? Let me see if I entered it correctly. Do that again. Y equals x squared minus 4x plus 5. Okay, I did minus 5. Okay, look what happens there. Okay, so this is now the graph of our parabola. Of course, when you graph this, you will not get the exact line that I'm doing it in. Okay, so you roughly graph it and you end up with your parabola. Okay, and that's how you graph your parabola using your axis of symmetry. Okay, and let's go back to this. So graph 0, 5, since it is symmetrical, the other 5 or the other side of the axis of symmetry would be 0, 5. This is 2 units to the left of the axis, go 2 units to the right of the axis, and that's exactly what we did. Okay, and then we repeat this for several other points, okay, for our parabola, and that's how you got this particular graph right here. And this is 0, 5, okay, and then we simply reflected 0, 5 over our axis of symmetry, which is in this case 4, 5. So that is the reflection of 0, 5, 4, 5 right there, and we simply connected those 3 points, and roughly that is the graph of our parabola. And if we check this, okay, we want to find out if 4, 5 satisfies the equation, and if we substitute the values of x and y to our equation, you notice that it will satisfy the equation. Okay, so it is part of the graph, and we have checked our answer. Okay, and that's how you graph your quadratic equation using the axis of symmetry. Okay, let's take a look at example number 2. In example number 2, the graph of the equation describing the height of an object propelled into the air can be an example of a quadratic function because gravity overtakes the initial force of the object falls back to Earth. Basically what it's saying is this: if you shoot something into the air, it goes up and then eventually it goes down. Okay, and that is a good example of a parabola. For the 4th of July, many cities have large fireworks displays that are coordinated with recorded music. Each rocket or firework, okay, explodes at approximately its highest point after being propelled into the air. The formula that describes the height is h of t of an object propelled into the air is h of t equals v sub 0 t minus 1/2 gt squared plus h sub 0, where v sub 0 represents the initial velocity in meters per second, t represents time in seconds, and g represents the acceleration of gravity, which is constant at around 9.8 meters per second, okay, squared. And h sub 0 is the initial height of the object at the time it is launched. Okay, so these are now the meaning of the variables that you see up there. Okay, so a certain rocket has an initial velocity of 39.2 meters per second, and it's launched at 1.6 meters above the surface of the water. So we want to graph the equation representing the height of the rocket, and we want to find out the maximum height of the rocket that the rocket achieves. And remember, maximum height talks about the vertex. Okay, you want to find that vertex. So suppose a rocket is scheduled to explode 2 minutes 28 seconds into a musical program. When should the rocket be fired? And that's in letter C. So let's do letter A first. Okay, in letter A, graph the equation representing the height of the rocket. So we graph that. Okay, so in letter A, use the given velocity and the force of gravity to determine the formula. So we rewrite the equation h of t is equal to v sub 0 t minus 1/2 gt squared plus h sub 0. and we simply substitute the value for his v sub 0, which is 39.2. So this becomes now 39.2, and substitute the value for gravity, which is 9.8. So this becomes 39.2t minus 1 half times 9.8, which is the acceleration of gravity, okay, t squared plus 1.6. Okay, 1.6 is the time it takes, is the h sub 0, okay, which is in this case 1.6 meters above the surface of the water. Okay, so if we simplify this further, we end up with 39.2t minus 4.9 t squared plus 1.6. Okay, so the values of a and b in this case, because we want to find our axis of symmetry, would be 39.2 and negative 4.9. Okay, so h of t corresponds to f of x, which is basically our y. T corresponds to our x. Okay, so we want to find the equation of the axis of symmetry to help you locate the vertex. So we use our formula for axis of symmetry. In this case, now it's going to be t equals negative b over 2a. Okay, again, substituting the values for b and a, which we talked about, is going to be negative 39.2, okay, all over 2 times negative 4.9. See, this is our a and this is our b, okay, which is 4 seconds. Okay, so using a calculator to find h of t when t equals 4, remember t is equal to 4, that means we need to square that and then use substitute the value, okay, substitute the value for t, which is equal to 4. We end up with h sub 4 equals 39.2 times 4 minus 49 times 4 squared plus 1.6, or 80 meters. So when we substitute t to our original equation, we end up with 80 meters. So our vertex now, when t is equal to 4, would be 4 and 80 meters. So at 4 seconds, the height of the rocket would be 80 meters. Okay, so we can use a table of values to find other points that justify this equation. So we found our vertex, our maximum point. Okay, so we can now use our table of values. Okay, using our table of values and using the same equation, these are given when t is equal to 0, height or h of t is equal to 1.6, all the way down when t is equal to 9, h of t is equal to negative 42.5. And if we graph those points, this is what we come up with. Okay, so in this case, again, we talked about independent and dependent variables. Time is always the independent variable, and the height of the dependent, the height is the dependent variable. The domain and range must both be positive. Okay, again, there's no such thing as a negative time or negative height. So the maximum height of the rocket in letter B is the vertex, which is 80 meters. And letter C, since the maximum height is achieved 4 seconds after the launch, the rocket must be fired 4 seconds before its scheduled explosion at 2 minutes, 28 seconds into the program. The rocket should be fired 2 minutes, 24 seconds into the program. Okay, because we want at 4 seconds it will reach its maximum height. So we need to fire the rocket 4 seconds earlier, okay, so that it will explode at its maximum height at 80 meters. Okay, so I hope that makes sense. If it doesn't, rewind it. Okay, the keyword for this particular lesson is sorrow. Keyword is sorrow. Okay, thank you for watching.